All right, we are going to do growing and shrinking objects. So we're making 3D objects either bigger or smaller. So here it says select a rectangular prism. So this is a video. So I'm going to randomly select something. I'm going to look like at a tissue box. Okay. So my rectangular prism is a tissue box. Okay. And it wants me to highlight what the shape is like. Remember, if I'm going fast, pause. If you need to hear it again, rewind. It's a video. You control it. So I'm going to go ahead and draw my rectangular prism. Something like that. And my width is going to be 2, and my height is going to be, my width is going to be 3, my height's 2, and this is 5. So I have a 3 by 5 by 2. What do you think will happen to the volume when you enlarge it by a common object by a given scale factor? So I'm going to go ahead and make a scale factor. I'm going to say, hey, we're going to make the sides 4 times as big. Now I want you to pause the video and fill in number 1. What do you think is going to happen to the surface area? Is it going to be 4 times as big or something else? Is the volume going to be 4 times as big or something else? So get ahead, pause, fill in number 1, and then come back. Okay, great. You filled in number 1. I'm not going to fill in number 1 right now. We're going to go through it and we'll come back to it. So here, record the dimensions. So my length is 3 inches. And I'm going to call my width the 5. And my height's going to be the 2. You can mix up width and length. You can't mix up the height. So since I said the height was 2 inches, I am calling the top and bottom my base. Now technically I can call the left and right my base, or the front and back my base, because they're all rectangles, so it doesn't really matter. But I'm going to go ahead and call the top and bottom my base. Okay, so draw a net. I have to think. I have 2 bases and 4 lateral faces, and they're all rectangles. So in total, I have 6 faces, but 4 in the middle and 2 sticking off. Okay. Again, the ones that are sticking off are my bases. And my base was 3 by 5. And my height was a 2. And these wrap around the base. So if that's a 3, this has to be a 5. This has to be a 5. And this has to be a 3. Okay. These 2 are my bases. And all of these are my lateral faces, the sides. This is also a face. It's a base face. Okay, surface area. We have to find the area of all of those rectangles. So I know I have 2 of my bases. Those are 5 by 3s. And I have 2 that are 2 by 5s, because the height's 2. So this is a 2, 2, 2, 2, 2. 2 that are 2 by 5s. And then what I have left are 2 that are 2 by 3s. So 15 times 2, 30. 10 times 2, 20. 6 times 2, 12. I added on up. That is 62 inches squared. The volume. I know that volume is area of the base times the height of the prism. Well, my base is the pink thing, 5 by 3. And my height of the prism is the distance between my bases, which is 2. So that is 15 times 2. That is 30 inches cubed. Okay. So this page, it told me to pick a rectangular prism. I did. I measured it. Eventually, I'm going to make it 4 times as big. You guessed at what is going to happen when I make 4 times as big. We're just measuring this one. We took our object, we found the surface area, and we find the volume. Next page. Imagine you're going to enlarge the object by building a scale model. Our model is going to be bigger. To do this, you'll multiply the dimensions by a number known as the scale factor. Choose a scale factor from 3 to 8. Okay, well, this is a video, so I'm choosing for us. My scale factor is going to be 4. That way it matches what you predicted up there. Multiply each dimension by a scale factor. Okay, so I had 3 length, but now I got multiplied by 4. So now I have 12 inches for my length. I had 5, but now I got multiplied by 4. So I have 20 inches for my width. I had 2, but now I'm going to multiply by 4. So I have 8 inches for my height. Compute the surface area. So I still think about the model. My dimensions are just different this time. Same type of thing. My dimensions are just different. I still have 4 lateral faces. And I still have my 2 bases hanging off. This is not to scale, just to give you an idea. My height is 8, so all of these are 8 because the bases are 8 apart. My base is 12 by 20. These sides wrap around my base, so if that's a 12, this has to be a 20. This is a 20, this is a 12. Okay, so once again, to find my surface area, I have 2 of my bases. So I have 2 12 by 20s. And I have 2 of these guys. Those are 8 by 20s. And I have 2 of the 8 by 12s. So 12 times 20 is 240 times 2 is 480. 8 times 20, 160 times 2 is 320. 8 times 12, 96 times 2 is 192. So when I add that on up, I get 992 inches squared. Volume. Area of the base times the height. My base is 12 times 20. My height is 8. So 12 times 20 times 8, I get 1,920 inches cubed. Okay, so I made something 4 times as big. I found the surface area and the volume. Determine the ratio of the surface area of the original option to the area of the model. Okay, ratio. That means write as a fraction. I have to do the original first, and then I have to do the model on the bottom. Okay, so surface area of the original over surface area of the volume, surface of the new, sorry. Okay, so looking back, my original surface area was 62. And my new surface area was 992, I have to reduce. First, I'm going to check. Does 62 go to 992? So 992 divided by 62. Yep, it does. That's 1 over 16. Determine the ratio of the volume of the original to the volume of the model. Okay, volume original, volume of the model. So here, my original volume was 30, and my model volume was 1,920. So I'm going to check if 30 goes into 1,920, and it does. That's 1 over 64. Okay, so now it's saying our hypothesis, but our hypothesis is talking about our scale factor, not our ratio. So here, if I want to go from the surface area of the original to the surface area of the new, that means I have to multiply by 16. If I want to go from the volume original to the volume new, that means I have to multiply by 64. So does it make sense that when I make my side of the original to my new, when I make it 4 times as big, should the area get 16 times as big? And I'm going to say yes, because area is 2-dimensional. So you have to go 4 times 4, which is 16. Volume is 3-dimensional. So you have to go 4 times 4 times 4, which is 64. Okay, so go check number 1. Did you write the right stuff? When I make the scale factor 4, the surface area will be 16 times as big. This makes sense because surface area is 2-dimensional. Okay, and then my volume will be 64 times as big. And this makes sense because volume is 3-dimensional. Okay, so was your hypothesis correct? You have to answer that. Explain what you found out. If the surface area, if the scale factor is A over B, the area ratio, or the surface area ratio, is going to be A squared to B squared. The volume is going to be A cubed to B cubed. If you had used a scale factor of 8, oh boy, okay, my scale factor is 8, 8 to 1. What would the factor surface area? Well, surface area is an area ratio. Surface area ratio. It has to be squared. So it would be 64. 8 times 8 is 64. 64 times as big. The volume has to be cubed. 8 cubed over 1 cubed. 512 times as big. The surface area would be 64 times bigger, and the volume would be 512 times bigger. summarize your findings. We just did that. If your scale factor is A to B, your area ratio squares. Your volume ratio cubes. Okay, if you need to put that into some words for yourself, then hit pause and go ahead and do that. All right, moving on, activity 2. For each of the following, find the necessary measurements to answer all the questions. A cube. Okay, so it's like a box with all the sides going around. So I'm going to go ahead and draw that. A cube. With side lengths 8. So 8, 8, 8. All this, the length, the width, the height, they're all 8. It's enlarged, so the side lengths are now 24. Okay, not to scale, obviously. "24, 24, 24. By what scale factor did the sides increase? So I have to think. 8 times what gets me 24? And I go, oh, that's 3. So my scale factor is 3 to 1. But what scale factor does the surface area increase? Well, I know if I have my scale factor is 3 to 1, then my area ratio has to be 3 squared to 1 squared. That is 9 to 1. How about volume? I know my volume ratio has to be A cubed to B cubed. 3 cubed to 1 cubed. 3 times 3 times 3 is 27 times as big. Okay, so we're practicing our ratios. All right, a rectangular prism with side lengths 5, 10, and 15. Okay, so I'm going to go ahead and draw that. Five, 10, 15, sure, something like that. Let me make my 10 a little better. Went down to 1 to 2 to 3. Oh, it shrunk. One to 2 to 3. What was the reduction? So if I went from 5 to 1, I divided by 5, or I multiplied by 1/5. So my scale factor is 1/5. Remember, when we are reducing, our scale factor should be less than 1. If we're enlarging, it should be bigger than 1. What would be the surface area and the volume of the new prism? Okay, so it wants me to start with the original one. So my surface area of my original, I have 2 rectangles that are 5 by 10, so I have to use the different combinations. 2 that are 15 by 10s, and 2 that are 15 by 5s. So 50 times 2 is 100, and 150 times 2 is 300, and 5 times 15 is 75, times 2 is 150. So my original was 550. My new one is going to be 1/5. My surface area new is equal to 1/5 of my original surface area. So I'm going 1/5 times 550. 5 goes into 55 11 times, so I get that makes scale factor, 1/25. Because if my surface area is 1/5, then my area ratio is going to be 1 squared over 5 squared, 1/25 times as big. Okay, so 25 goes into 550. So quarter into $5.50, that is going to be 22. It'd be 20. This is inches squared, and this would be inches squared. It'd be 25 times smaller. We have to do for volume. Volume original, so much easier to find volume. 5 times 10 times 15. That is 750 yards cube, or what are we on? Oh, I put inches, but this is yards. Let's split that up. Yards, yards, yards. Yards squared, yards squared. Yards cubed. My volume ratio is 1 over 5 cubed. 5 times 5 times 5, 125. So my new volume, I need to go 1 over 125 times 750. And I get 6 yards cubed. Now I know I'm right because 1 times 3 times 2 is 6. Okay, so area ratio is 1 over 25. Volume ratio is 1 over 125. Number 16, a rectangular prism that's 2 by 3 by 5. All right. Is enlarged. All right, it's getting bigger. Woohoo! To some new volume. New prism that has a volume of 240. All right, well, here I have size and here I have volume. So if this is the volume, I'm not sure what the sides are right now, but I can figure out what the volume is over here. So I have to work backwards. I have to go, okay, I got to compare the same things. I'm going to compare volume. So here, the volume is 2 times 3 times 5. 2 times 3 times 5 is 30. I'm going to figure out what got multiplied here. My volume ratio to get from 30 to 240 is I have to multiply by 8. Now, I know my volume ratio is my scale factor cubed. So I have to think, what multiplied by itself 3 times gets me 8? So 1 times 1 times 1, that's 1. 2 times 2 times 2, oh, that's 8. So my scale factor is 2 over 1. So the sides are 2 times as big. So 2 went to 4, and 3 went to 6, and 5 went to 10. So it's 4 millimeters by 6 millimeters by 5 by 10 millimeters. All right, what's the new surface area? All right, well, my new surface area, I'm going to have 2 rectangles that are 4 by 6s and 2 rectangles that are 6 by 10s. And I think what other combination did I use? I didn't use the 4 and the 10 together. 2 rectangles that are 4 by 10s. So 24 times 2, 48. 60 times 2, 120. 40 times 2, 80. So 248 millimeters squared. All right, next one. Draw a net for the square base rectangular prism to the right. Okay, fine. So my other base is also the square. Okay, so I have 4 rectangles for my lateral faces. And my bases are squares coming off the side. Not perfectly to scale, but that's basic idea. Suppose the above prism dimensions are 8 by 8 by 12. Okay, so 8 by 8 by 12. That means these are all 12s because that's the distance between the bases. And this is 8 by 8. It wraps around, so these are also 8s. Suppose the prism has a dimension 8 by 8 by 12. Did it? Find the surface area and volume. Okay, surface area. I've got 2 of the bases. They're 8 by 8s. And then these are all the same. And there's 4 of them. 4 8 by 12s. So 8 times 8, 64. 64 times 2, 128. 8 times 12, 96. 96 times 2, 384. Add them on up. 512 inches squared. Volume, multiply them. 8 times 8 times 12. I need my calculator for that. 768 inches cubed. Still using the above prism, find the new dimensions if they were scaled by 3/2. Okay, so my 8 times 3/2 gets me 12. And it's a square, so 12 millimeters by 12 meters. And then my 12 times 3/2, 2 goes into 12, 6, 6 times 3, 18. So by 18 millimeters. Surface area. I have to go 3/2 squared times my old one, 512. So I'm going 9/4 times 512. So 9/4 times 512, my new surface area will be 1,152 inches squared. My volume, the cube, I have to go 3 cubed over 2 cubed times my old volume. 768. Okay, so 3 cubed. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. I have to multiply that together, and I get 2,592 inches cubed. Still using the above prism, find the new dimensions if you scaled it by 2/3. So my original one. 8 times 2/3, I'm making it smaller. 12 times 2/3. So here I get 16/3 millimeters. It's a square. By 16/3 millimeters. By 3 goes into 12. 4 times 2 is 8 millimeters. The surface area, I have to square that. 2 squared over 3 squared times my original, 512. So this time I'm going 4/9 times 512. When I go 4/9 times 512, I don't get a nice number. 227.5 repeating inches squared. My volume ratio, I have to go 2 cubed over 3 cubed times the original. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Then I put that in my calculator, and I don't get the nice number, but coincidentally, I get the same thing. Inches cubed. All right. Last one. Cube A has a surface area of 18. Cool. The edge of the lengths of B are 3 times as long as the edge lengths of A. So that's giving me a scale factor. Scale factor is 3 to 1. So my area ratio should be 3 squared to 1 squared, which is 9 to 1. So my surface area should be 9 times as big. 18 times 9, 162 centimeters squared. All right, hit save, turn it in. I'll see you next time.